Today we shall see the same type of problems, which I'm going to call as type 1 problems. Okay, and then type 1 problems, we are talking about only the independent sources. I'll just talk a few words regarding the dependent and independent sources. See here, dependent sources, the independent sources come with this symbol. Understand that? This is voltage source, this is current source. Okay, they are independent. Fine. Dependent sources come with this symbol. Fine. If it is like this, it is current. Okay, and if it comes with the polarities, then it is voltage. Okay, I'll be talking about this later, not now. Okay, we will talk about this later when we see problems with dependent current sources. They are dependent. Okay, they are dependent sources. Dependent sources. Okay, so which we shall see later, not now. Okay, so what we are doing is we are considering the circuits only containing the independent voltage and current sources. Okay, in that, in the first category, we are calling as type 1 category. In type 1 category, what's happening, we are considering circuits only with voltage sources. See, we are considering circuits with voltage sources only, mind you. Okay, so no current source, no current source. You have to remember this. Fine. So now with me, take down the circuit. Fine. The first problem that we are taking today. Fine. So you will be solving a lot of problems. So make it a habit to keep pen, book, everything in front of you, and keep writing as and when I put things on the screen here. Okay. The first problem in type 1 category. What are type 1 category? Circuits only with independent voltage sources with no current sources. Okay. Now just copy it down fast, everybody. Copy it down. Everybody, I hope you're copying. Copied. As much you write, it's good, because you should become good with writing circuits. If you don't write, you will not be good. I'm still trying it to be good with this electronic pen and tab. I'm much better than what I was in my first class, but yes, I can always improve. Okay, the circles can be better. Yeah. Now take down this. This is 0.2 ohms. This is 2 ohms, 5 ohms, 4 ohms, 3 ohms, and 0.2 ohms again here. Mind you, okay, these two are voltage sources, plus minus, and this is given to be 10 volts. This is also plus on the top and minus here, and it is given to be 15 volts. Everybody's okay with this? Fine. What they have asked us is to find the mesh currents. Find the mesh currents is the question. Okay, so if we have to find the mesh currents, what do we need to do? Mesh currents means by mesh analysis. Okay, so it's understood that we are doing this by mesh analysis. Everybody's okay with this? We are finding mesh currents means it's by mesh analysis. Anything we find by mesh analysis is first finding mesh currents. Understand? So what did we do in the previous example that we discussed? We have to count the number of meshes. Can anybody give me the number of meshes here? How many number of meshes are there? Anybody? See?
3.
Exactly. Good. This is one mesh, second mesh, third mesh. So there are 3 meshes. That means we'll have 3 mesh currents. Okay. Everybody mark these mesh currents. Let's call this as IA. Okay. This as IB. Okay. And the current here as IC. So we have 3 meshes. So we have marked 3 mesh currents. Now I'll be referring to these meshes as mesh 1, mesh 2, mesh 3. Which is our mesh 1 now? The current IA, where it is flowing. The mesh where IA is flowing is referred to as mesh 1. This is mesh 2, this is mesh 3. See, IA can come here, IC can come here, IB can come here. Anything can happen. At the end, what we will see, okay, in this mesh, what is the current? You can name it as anything. Everybody understand that? You can name it anything. Okay. Now, Raksha, you have anything to ask? Yes? Fine. Now, let's apply KVL now. Fine. Solution. Let's go to the solution. I'll give solution here itself. What are we doing now? First, we are applying what we are applying. We are applying KVL to mesh 1. KVL to mesh 1. Those who are not comfortable with this, please see it once before you write. Okay. Now, what is that? What is that I'm trying to get you? See, this is our mesh 1. This is our mesh 1. Okay. So here I'll be moving in clockwise direction. When I'm moving in clockwise direction, I'm coming across minus sign of this 10 volts. So it is minus 10. Then this is 0.2 ohms. How many currents are flowing through this 0.2 ohms? Only IA is flowing. So it is 0.2 IA is the voltage across this. But if the same current comes across this 2 ohms, when it is flowing through these 2 ohms, it's not only IA flowing through these 2 ohms, IB is also flowing. But since we are operating in mesh 1, when we are moving to the right, IB is moving to the left. Everybody understand? So that's why it is IA minus IB into 2. Okay. So everybody observe here. It is minus 10. Okay. Plus 0.2 IA plus 2 IA minus IB. Okay. Plus 3. What? Plus 3 into what? See here, through this what's happening? IA is coming downwards. IA is coming downwards, whereas IC is moving upwards. Okay. Since I'm in mesh 1, okay, I have to consider IA as positive because I'm also moving downwards. IA is also moving downwards, but IC is moving upwards. So it is IA minus IC. So it is 3 into IA minus IC. Okay. See here, it's 3 into IA minus IC equal to 0. So I've taken all the voltages here. Algebraic sum of all these voltages should give you 0. How many voltages there? See here, voltage number 1 across this 2, across this 3, across this 4. So totally we have 4 voltages. Algebraic sum of these 4 voltages should give you 0 according to the Kirchhoff's voltage law. Now bring this to the standard form. What standard form? Now group the scalars with IA one side. Okay, how many IAs are there? It's 2 plus 3, 5 plus 0.2. So it is 5.2 IA in its standard form. 5.2 IA. How many IBs? Minus 2 IB. Okay, then minus 3 IC. On the right hand side, you will have 10. So this is your equation number 1. Is everybody okay with this? Can you similarly do it for mesh 2? In mesh 2, there are no voltage sources. How many drops would be there then? 1, 2, 3. 3 drops are there. So sum of the algebraic sum of these 3 drops should give you 0. So go on KVL to mesh 2, everybody. KVL to mesh 2. KVL to mesh 2. So what's happening there? Yeah. Let's start from this 2 ohms. Let's start from this 2 ohms. Okay. So it's 2 into, now I'm operating in mesh 2. Okay. So I'm moving in this direction. IB is moving in the clockwise direction only, but when I'm moving to the left in this 2 ohms, IA is moving to the right. See, IB is moving like this, IA is moving like this. So see, it is 2 into IB minus IA since I'm in mesh 2. Okay, so it is 2 into IB minus IA. Through this 5 ohms, only IB is flowing. Okay, so I'll just write that as plus 5 into IB. Okay, through these 4 ohms, what's happening? Through these 4 ohms, again, there are 2 currents. IB to the right, whereas IB to the left, IC to the right. Since I'm operating in mesh 2, okay, the current in mesh 2 would be positive. So in that sense, I can write this as plus 4 into IB minus IC equal to 0. Okay, quick, bring this to the standard form. This is standard form. This is standard equation number 1 in its standard form. Let's bring equation number this equation also in standard form. So it is minus 2 IA. How many IBs? 2 plus 5, 7. 7 plus 4, 11. 11 IB minus 4 IC equal to 0. Call this as equation number 2. Everybody go with mesh 3. Go with mesh 3, everybody. Fast. Go with mesh 3. KVL to mesh 3. Okay, let's write that as KVL to mesh 3. Fine. Now, what happens now? What happens? We have to operate in this particular mesh. Okay, let's do that now. Let's do that. Yeah. This is here. I'll start from 3 ohms. So it's 3 into IC minus IA plus 4 into IB minus, sorry, it's not IB, huh? It's not IB, sorry. It's IC minus IB since I'm operating in mesh 3. Okay, plus 0.2 IC. Okay, and I'm approaching positive sign of this 15. See here, when I'm coming like this, I'm approaching positive sign of this 15. So I'll write that as plus 15 IC. I have done a mistake here purposefully. Can anybody tell me what is that mistake? Observe this equation. Here I have done a mistake. Here I have done a mistake. What is that mistake? Anybody want to?
15 into IC Barbard.
Yeah, IC Barbard. It should only be 15. See, we're writing the voltages. 15 is already a voltage. 15 itself is a voltage. 0.2 IC is a voltage. Okay. Then 15 is the voltage. So most of the students, when they are doing this in a hurry, write this as 15 IC, which is wrong. Okay, so we are writing the voltages, mind 15 volts itself is a voltage. So again, attaching IC there along with 15 volts would make it wrong. Okay, so it is just 15. Bring this to the standard form fast and take your calculators. And I've given you, I've posted some videos in your WhatsApp regarding the calculations, how to find these unknowns here, solving simultaneous equations. I've named it as. Okay, you can go through that. If you don't understand, you can learn it from me, not a problem. Now bring it to standard form. It is minus 3 IA. How many IBs? Minus 4 IB. How many ICs now? 3 plus 4, 7 IC, 7 plus 0.2. So it's plus 7.2 IC equal to this plus 15 would come to the right hand side. So it would be minus 15 on the right hand side. Okay. Now what I want you to observe here, everybody just give your time to me. Everybody observe here. Okay. See, this here. Let me take that. Yeah, this equation. Okay, which current is positive now? See, this is positive in mesh 1. Okay, see in this equation, IB is positive because this is mesh 2 equation. The other terms are negative. In this equation, what's happening? IA and IB terms are negative, whereas IC term is positive. That means whichever place you are in, okay, so whichever mesh you are in, the current in that mesh would be a positive entity. Everybody understand that point? Okay. Now you have to solve this. Now. How to solve these equations? Fast. You can solve yourself. Okay. Anyways, I've posted the videos. If you don't know how to solve, take out your calculators. Okay, and go for the option equation. Okay, and mind you, we have 3 unknowns now. Fine. Solving 1, 2 and 3. Solving 1, 2 and 3 using calculators is what is understood. You need not have to write it again. Okay, or you need not have to take any mathematical method to solve this. The calculators are meant for this only, so you are using the calculators. I already have the results for this. You can just copy it down. Yeah, I1 is IA rather. Okay, IA is happening to be 0.11 amps. Put that in bracket. Put that in box rather. You're highlighting it. Okay. Then IB. IB is minus 0.9 amperes. Okay, put that in box again. IC is, anybody, if you obtained it?
Minus 2.53.
Minus 2.53, good. Minus 2.53 amps. See, those who don't know how to calculate this using the calculator, please learn. It has been given. It's very easy. Okay, it's very easy. Do it for one. It's the same for. There are 2 types of calculators. One is the old version, another one is new version. They are little different. Okay, both the videos have posted. You can go through them and you can learn if you don't know. Fine. Let's move on with the next. See here one more thing that I want to tell you. Find mesh currents. So when they say find mesh currents, these mesh currents were not given. We have marked this to begin with. Okay, so this IA, IB, IC, something that I have marked in red, were not given in the problem. So what we should do before we proceed with the solution is, okay, mark you have to say this: mark IA, IB, and IC as shown in the solution. So you should say it in the solution, because IA, IB, IC, if it is marked, it's fine. Otherwise, if it is not marked, you have to mark it, because without marking, you cannot find the mesh currents. Understand that? Now, let's move on with the next problem. Okay, that is, I'll take the same, okay, and I'll ask you to find the voltage. Everybody see here, what I'm doing. I'll copy this. It's not allowing me now. Okay, suppose everybody, just for this, just for the sake of discussion, suppose there is a V naught here. How to find out V naught? Anybody? Suppose they say find V naught by mesh analysis. What is that we are supposed to be doing? Yeah. Anybody would like to talk upon that? What is V naught? What is V naught?
IA minus IC by 3.
IA minus IC by 3. What is V given by? V is I into R, isn't it?
Sorry, sir. Multiplied by 3, not divided by 3.
Yes,
Multiplied.
yes, good. See here, I'm taking the same circuit here. Fine. That's what I'm saying. Suppose you need to find out, okay, V naught. What do we need to do is the question. Okay, so here is V naught. Okay, V, you should not forget. V is what? V is I in. V is given by, see here, V is given by I into R. Here, what is asked to be found out? Suppose we are asked to find out V naught. Fine. We already have found out all the mesh currents. IA, IB, IC is already been found out. Now we need to find out V naught. So V naught also is current into resistance. Resistance is understood. Resistance is 3 ohms. Okay. Resistance is 3 ohms. But through 3 ohms, there are 2 currents flowing. Understand that? See, there is IA flowing, there is IC flowing. So V naught that is dropping across 3 ohms is not only because of any one current, it's because of both the currents that is flowing through 3 ohms. Okay, and among IA and IC, which current is approaching the positive sign of V naught? That you need to look at. See here, if you see the current flow here, where current is flowing, okay, so if you see where IA is flowing, you will see that IA is approaching positive sign of V naught, and similarly if you observe IC flowing, IC is approaching negative sign of V naught. Okay, so that's why I consider V naught equal to IA 3 into IA minus IC. Everybody get this point? So V naught is IA into IC. I again tell you that IA is taken positive because IA is approaching positive sign of V naught. That's why it is IA is positive. This is approaching negative sign. Everybody understand that? Since IA is approaching the positive sign of V naught, it is positive. Since IC is approaching negative sign of V naught, it is taken as negative. So it is 3 into IA minus IC. Everybody understand that point? Okay. So let's substitute the currents that we have just found out. Everybody do that. What is IA that we have just found out? IA is found out to be what? Let's see that. IA is found out to be 0.11. Okay, therefore our V0 is 3 into 0.11 minus IC is negative, is minus of minus 2.53. Okay, so V0 would be given by, I have calculated that value, it is coming as 7.92 volts. Get this point, everybody? It is 7.92 volts. Fine. So when did we find out this V0? Why we took this example? We already have, in the first place, we already have considered the finding of mesh currents. Okay, so how did we find out mesh currents? We have found out mesh currents by mesh analysis. So already by mesh analysis we have this. Once you have these currents, mesh currents in hand, how to find out this V0 is what we have seen. Okay, so what we have done is, okay, after finding out the mesh currents, okay, after finding out the mesh currents is what we have done. How to find out V0? After finding out mesh currents, how to find out V0 is what we have seen. We can also see how to find out a current. Okay, so let's say that there is a current flowing here. Okay, so let's take a current flow I0. Fine. So how to find out this I0 after we have found out the mesh currents? I0 is not a mesh current, mind you. Okay, how to find I0 is the question. Fine. Now through 4 ohms, again there are 2 currents flowing. One is IB, the other is IC. IB, IC. Now what is the task? We have expressed V0 in terms of mesh currents, right? Now we have to express this I0, which is a branch current, in terms of the mesh currents. How can express I0 in terms of IB and IC? Needs to be seen. Okay, so IB and IC is also flowing through 4 ohms. Okay, but IB is flowing to the left hand side, whereas IC is flowing to the right hand side. When you see that clockwise movement, okay, you can see that IB is flowing to the left hand side and IC is moving to the right hand side. And where is I0 moving? I0 is moving to the right. So identify the current which is moving in the direction of I0. Okay, and that current would be positive, and the current which is moving opposite to I0 would be negative. So in that sense, what is I0 now? I0 would be IC minus IB, because IC is flowing in the direction of I0, whereas IB is flowing opposite to the direction of I0. So I can say my I0 is given by, in terms of mesh currents, I mean, is given by IC minus IB. What is IC? IC is minus 2.53. What is IB? IB is minus 0.9. Yeah, IB is minus 0.9. Okay, so in the bracket you have to take minus point. So you need to be really careful with the brackets there. Okay, so this gives us I0 equal to minus 1.63 minus 1.63 amps. Now I0 is happening to be negative. What is the meaning of that? I0 is happening to be negative. What is the meaning of that? See here, I0, the given I0 is flowing to the right. If this I0 had given as a current flowing to the left, then this would have come positive. Since it is in the given direction, I0 is negative, which means that the positive I0 would be flowing in the opposite direction. That is how you need to look at. Okay, the sign of the current tells the direction, whereas the sign of the voltage tells you the magnitude. Everybody understand that? Okay, so this is how we can find out the branch currents and the branch voltages in terms of the mesh currents. Everybody get that point? Now let's see this problem. Okay, in this problem also we have to find out the voltage V0 and current I0. Okay, I'm not going to solve that now itself. Okay, so this you can take as assignment, do it yourself. I'm just giving you what is that you're supposed to be doing. Okay, as the steps that we followed in the previous problem. What is that step we need to follow here? Let's look at. What is that we need to look at is in the solution. First, in the solution, I'll just give you what all you need to do. First, how many meshes needs to be answered? Okay, then second part is mark mesh currents. Okay, what is third step? After marking mesh currents, what do we do? Apply KVL to find mesh currents. To find mesh currents. What is the last thing? They have not asked us to find out the mesh currents, but since they have told us to do this by mesh analysis, we have to be finding out the mesh currents. Everybody understand that? Now what we need to do? We need to find V0 and I0 they have told. Okay, then find V0 and I0. How we'll find out V0 and I0? Express V0 and I0 in terms of mesh currents. So this is what you will do. Okay, how many meshes are there? How many meshes are there? See, this is one mesh. This is mesh number 1, mesh 2, mesh 3. Very similar to the previous problem. Here also we have got 3 meshes, right? But the arrangement of meshes is different here. The arrangement of circuit is different. Though there are 3 meshes, the circuit arrangement is different. Okay, here it's a different circuit, but having the 3 meshes only. So how many meshes we have? We have 3 meshes. Okay, so the things look simple here. Okay, so that's why you can easily make out there are 3 meshes. So once there are 3 meshes, what you will mark? You have to mark IA, IB and IC. 3 mesh currents need to be marked. Then apply KVL to mesh 1, mesh 2, mesh 3. Okay, and solve the equations to find the mesh currents. Apply KVL to solve mesh currents. So how many KVLs you will have? How many KVLs you will have? You will have 3 KVLs and 3 unknowns. So 3 equations, 3 unknowns easily you can find out by using the calculators. I'm again telling you, okay, so you have to learn the usage of calculator by looking into the videos that I have posted in your group. Okay, so once you have your mesh currents, IA, IB, IC, you can express V0 and I0 in terms of IA, IB, IC. Okay, with that, finish off that, and let's again meet and discuss some more things in the next class.